Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kaalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day.
Good morning! It's another sunny and blessed day for us, lalong-lalo na sa ating grade 10 SSC learners. Good morning din po sa lahat ng dance faculty and staff, headed by our very loving and supportive officer in charge, as well as the Chief of the Curriculum Implementation Division of SDO Isabela, Dr. Rodrigo V. Pasqua. Nakahapon lamang po ay nag-celebrate ng kanyang kaarawan. Happy birthday po uli, Sir Rod. Yan. Special greetings din po sa ating mga head teachers. And of course, the head teacher of Science Learning Area, Ma'am Annabel Rodriguez. Shout out po sa mga 10 Rutherford, 10 Einstein, at 10 Mendeleev na hindi pa nakakabangon. Mga anak, galaw-galaw na po. Bangon na at simula ng ating araw. Yan, sit back because we are about to start our RBI airing about Bernoulli's principle in few moments. Abangan ang ating trivia questions with electronic loads as prizes for the winners. So please, stay tuned.
Dance Radio, silid-aralan sa radyo, hatid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta na magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science.
Good day, everyone, especially to our grade 10 SSC learners. I hope everybody is doing great in his or her studies while staying safe at home. I am Teacher Bernoulli, your radio teacher in advanced physics. Are you ready to kickstart learning in today's lesson?
Yes, ma'am.
Well then, make sure you have with you your learning activity sheets in advanced physics for week 2 titled Fluid Dynamics and Bernoulli's Principle and their Applications. And of course, your pen for the writing of notes. Can you hear me clearly?
Yes, ma'am.
Please sit comfortably and get ready for another journey around the world of physics. Okay, let's start! Last week, we discussed Pascal's principle and its applications. Can you share what you have learned from the discussion?
Ma'am, I have learned that pressure in confined fluids can be transmitted undiminished throughout the fluid.
Very good! That's correct! When a fluid is confined and you exert a force on any part of the fluid, in other words, you exert pressure on it, the pressure can be transmitted undiminished throughout the fluid. And that is known as what physics principle?
Pascal's principle, ma'am. Unknowingly, I apply Pascal's principle whenever I press a tube of toothpaste and a lotion or gel bottle, ma'am.
Very good! Those are actually practical applications of Pascal's principle. In what other situations is this principle applied?
Ma'am, Pascal's principle is applied whenever a driver presses on the brake pedal of a vehicle. The brake fluid, which is confined in a tube, is also pressed, transmitting the pressure on the brake cylinder found on the wheels. This transmitted undiminished pressure stops or slows down the car, ma'am.
Wow! Great job! You really learned a lot. In addition to what you have shared, machines that operate by transmitting pressure through a liquid called hydraulic machines are also common applications of Pascal's principle. These machines include hydraulic lifts, hydraulic presses and jacks, hydraulic motors in caterpillar trucks, and chairs used by dentists, barbers, and others.
Pascal's principle is just around us.
Yes, you were correct. It seems that you are now ready for our lesson for today. After learning over the radio, you are expected to number 1, explain Bernoulli's principle. And number 2, cite practical applications of it. So get ready for fun-filled learning in advanced physics. We'll be back after a short break.
Uy, Pedro! Nagpabakuna ka na ba?
Oo naman, Petra. Bakunado na yata to. Dapat ang bawat isa ay mahikayat ng magpabakuna. Bata, matanda, tara na!
Tama ka dyan, Pedro! Kung may bakuna, siguradong protektado tayo laban sa virus. Kaya magpapavaksin na rin ako.
Tandaan, magpabakuna, siguradong protektado ka.
Isang paalala mula sa Tonyong Aurora National High School at ng himpilang ito.
It's Science Time!
You are listening to Teacher Benjulu.
And I'm back! Now, let's get started. How do airplanes fly? Do you have any idea how they generate a lift?
They should have a good set of wings and strong motor, ma'am.
The planes need to overcome the force of gravity, ma'am.
Ma'am, the plane should accelerate uniformly to take off.
Wow, you are all right. But there is something that you missed to look into, which plays a very important role in the flight of an airplane. That would be uncovered as we go through this lesson. So stay tuned and discover the secret behind their flights.
Aye, aye, Captain!
Okay, let's begin. Do you know what a fluid is?
Yes, I do, ma'am. Fluid is defined as a material that flows and conforms to whatever container it is in.
Ma'am, liquids and gases are examples of fluid because they can be made to move or flow.
Great! Good job! You have the correct idea of what a fluid is. Fluids have the ability to flow just like air and water. These fluids experience two types of flow called laminar and turbulent flow.
Ma'am, laminar or turbulent flow?
Yes, laminar flow occurs when water flows smoothly in rivers or through a pipe and when the wind blows gently. While turbulent flows occurs when there is an irregular motion of fluid as it passes over an obstacle, setting up whirlpools and eddies.
So turbulent flow occurs when water hits rocks and other physical barriers as they flow and when the wind is strong and irregular during typhoons, ma'am.
That's right. Laminar flows are smooth and streamlined, whereas turbulent flows are irregular and chaotic. In which type of flow do you think fluids move faster?
I think fluids flow or move faster in turbulent flow than in laminar flow, ma'am.
Very good! Good job! Yes, fluids have a faster speed during turbulent flow than when experiencing laminar flow. The velocity of the fluids as they move actually plays a very important role in the flight of airplanes.
What's the role of the fluid's velocity in the flight of an airplane, ma'am?
Okay, it's time for me to introduce you to one of the fascinating physics principles, Bernoulli's principle.
Bernoulli's principle? Is that the principle formulated by the Swiss mathematician named Daniel Bernoulli, ma'am?
Yes, it is. Bernoulli's principle states that faster moving air has low air pressure and slower moving air has high air pressure.
So the air that is experiencing a turbulent flow has low air pressure since it is moving fast, while air that is having laminar flow has high air pressure, ma'am, because it is slow moving. Am I correct, ma'am?
Yes, you are, my dear learner. When a portion of air experiences laminar flow and the other portion is in turbulent flow, we expect that this air have different air pressures. The one in laminar flow has a high air pressure, while the other one in turbulent flow has a low air pressure. Don't you know that when air has different air pressures, one of them pushes the other?
Wow! Which one does the push, ma'am?
It's the air with higher pressure or the one in laminar flow. When there is a difference in air pressure, the air with higher pressure pushes the air with lower pressure. Or, in other words, the air in laminar flow pushes the air in a turbulent flow.
If one of them is pushing the other, then there would be a movement, ma'am.
Absolutely. Imagine an airplane is in between this air with different air pressures. The air on its bottom is in laminar flow, while the ones on top are in a turbulent flow. What do you think would happen?
If an aircraft is in between this air that is flowing differently, I think the air at the bottom will push the air at the top, which will also generate lift to the aircraft, ma'am.
What a bright idea! Good job! What made you think so?
Ma'am, if the air on top of the plane is turbulent flow, that means it has low air pressure, and if the ones on its bottom are in laminar flow, that also means this air has high air pressure, as stated in Bernoulli's principle. When there is a difference in air pressure, the high pressure air will push the low pressure air. In this case, the push is directed upward, generating a lift on the plane, ma'am.
That's correct. You really got good reasoning and critical thinking skills, my dear learners. Let me test your skills once more. How does the shape of the wings of airplanes help them achieve lift?
The wings of the airplanes have bulged on top so that air flows faster over the top of the wing and is lower underneath. Fast-moving air equals low air pressure, while slow-moving air equals high pressure. This difference in air pressure produces lift to the plane or the ability to get into the air, ma'am.
Great job! That's correct. Good job! The shape of the wings makes the air on the top move in turbulence, producing lower air pressure at the top than at the bottom, which would eventually generate a lift on the aircraft. Is it clear to you now how airplanes fly?
Yes, ma'am.
That is actually just one of the many applications of Bernoulli's principle. Let me mention you some more. When a truck moves very fast, it creates a low pressure area. So clouds of dust are being pulled along in the low pressure area.
That's why we always get a dusty road when jeepneys and tricycles move fast along the highway.
Yes, it's not only that. Fast-moving trains and trucks can pull nearby objects because of the same reason. That's why it is not safe for us to get nearby fast-moving objects. We can be pulled towards them.
That's really not a good idea, ma'am. I think it's also the same reason why roofs are blown away by heavy winds during strong typhoons, ma'am.
Yes, you are right. During heavy winds, the velocity of air is stopped by the walls of the house, but the velocity is very high on rooftop, which creates a lower pressure zone on the rooftop. But inside the house, the air velocity is very less, and hence, the pressure is very high as compared on the rooftop. High-pressure air inside the room tries to move towards a low-pressure area, and hence, the roof is lifted and blown away sometimes. Bernoulli's principle is also applied in the operation of hair blowers, vacuum cleaners, alcohol sprayers, and the like.
I now appreciate how Bernoulli's principle is applied in our daily lives, ma'am.
Oh, I'm so glad to hear that. Okay, let's continue after the short break.
COVID-19 has caused loss of lives and economic hardship all over the world. It has changed our habits and the way we live while testing our public health systems and impacting on our livelihoods. With this, the role of environmental health practitioner has never been more vital as we face up to the ongoing challenges this pandemic. Many changes are about to happen for a greener environment, more equal and more stabilized economy. COVID-19 pandemic has resulted numerous impacts on the environment and climate. But amid this crisis, we have a chance to build a better community and environment. Hashtag healthy environment. Hashtag healthy community.
It's Science Time!
You are listening to Teacher Benjulu.
And I'm back. Did you learn from our discussion today?
Yes, ma'am. We actually learned a lot.
Very good. Before we sum up our lesson, I want you to open your learning activity sheets for this week and let us go over the activity for Bernoulli's principle on page 4. In this activity, you have to answer the following questions based on the concept discussed a while back. First, What causes the roofs of houses to be lifted and blown away by strong winds? Again, what causes the roofs of houses to be lifted and blown away by strong winds?
Ma'am, it's the difference of air pressure inside and outside the house that lifts the roof and blow it away during strong typhoons. The rushing air on the top of the roof creates low air pressure zone, while still air inside the house creates high pressure zone. As what we have discussed, high air pressure pushes low air pressure. It is the air from inside the house that pushes the roof upwards, not the strong winds from the outside, ma'am.
Very good! Good job! Second, relate the open design of both ducts and piers to Bernoulli's principle. I repeat, relate the open design of both ducts and piers to Bernoulli's principle.
Ma'am, piers are actually built with wooden stakes and water underneath instead of a concrete cement. The open design of both docks and piers help the boats to dock safely. As the boat approaches the pier, it displaces the water between itself and the pier, moving it aside. This motion would cause the pressure of the water between the boat and the pier to drop, and the difference in pressure between the water and the pier would cause a rightward force on the boat that would slam it into the pier. By building a pier on top of wooden stakes that permit water flow, the displaced water simply slides under the pier, preventing the difference in water pressure from building, ma'am.
Very good answer. You were correct. Good job! Third, give 2 additional applications of fluid dynamics and explain each comprehensively. I repeat, give 2 additional applications of fluid dynamics and explain each comprehensively.
Bernoulli's principle is also applied on the operation of chimneys and exhaust fans of large buildings, ma'am. Bernoulli's principle uses wind speed difference to move air. Architecturally speaking, outdoor air farther from the ground is lesser obstructed, so it moves faster than the lower air and thus has lower pressure. This lower pressure can help suck air from the chimney, ma'am.
Very good! You may continue to answer the rest of the activity. Make sure to give your answer in your own words. You might be searching in the web for help, but be sure to understand the concept and state your answer in your own words. By that, learning would be more meaningful.
Noted, ma'am.
Great! Let us now sum up what you have learned today. Can you share your takeaways from this discussion, my dear learners?
Ma'am, I learned that fluids move into different ways. First, through the laminar flow, where the fluid flows streamlined and smooth with regular paths. Second, through the turbulent flow, where it moves violently and chaotic and undergoes fluctuations. In turbulent flow, the fluid forms eddies or small packets of fluid particles.
Very good! What other else?
I learned that Bernoulli's principle states that an increase in fluid speed creates a pressure decrease and a decrease in a fluid speed creates a pressure increase, ma'am. This difference in fluid pressure makes the high pressure zone push the low pressure zone.
Ma'am, I also learned that Bernoulli's principle accounts for the flight of different aircraft, gliders, insects, and birds. It is also responsible for the operation of hair blowers, vacuum cleaners, and the like.
Great! You correctly understood the salient points of our topic today. Now, I would like you to answer the following questions for me to gauge how much you have learned from the discussion. Number 1. What type of fluid motion is exhibited when the fluid moves in irregular and chaotic pattern?
Turbulent flow, ma'am.
Very good. If the motion of fluid is smooth and regular, the fluid shows what type of flow?
The fluid is having laminar flow, ma'am.
That's correct. Who formulated Bernoulli's principle?
It was Danielle Bernoulli, ma'am.
Great job! Now, kindly state Bernoulli's principle.
Bernoulli's principle states that air with higher velocity has low air pressure and air with lower velocity has high air pressure, ma'am.
Very good! Good job! Can you give me some applications of Bernoulli's principle?
Bernoulli's principle is responsible to the flight of airplanes, birds, kites, and others, ma'am.
It is also the reason why some roofs are blown upwards by strong winds during strong typhoons, ma'am.
This principle explains why it is not safe to stay close to fast-moving vehicle like trains and trucks. We might be pulled towards the low-pressure zone that these vehicles create, which may cause accident, ma'am.
Very good! Good job! You really learned a lot from the discussion, my dear learners.
We do have a lot of takeaways today, ma'am. Learning about Bernoulli's principle makes me realize that in life, for you to be able to gain a lift and fly high, you must be willing to be pushed towards your goal by the high pressures underneath you. Pressure in life is not always a negative thing. It actually pushes us up to move towards our goals.
Wow! That is an amazing realization. I am learning from you too. I think you are now equipped with knowledge about Bernoulli's principle. Stay tuned and listen to the continuation of this lesson via Facebook Live with your advanced physics teachers. We're almost done. I hope you have learned a lot from our discussions. Do not forget to ask your subject teachers through their mobile phones or messenger chats if you have questions about this lesson. Always tune in on our station for more learning opportunities. That's all for today. Before we end, I would like to acknowledge the teachers behind this School on the Air lesson. Teacher Benjelu P. Santiago, the scriptwriter. Teacher Ryan Colcol, our technical specialist. Teacher Prince Donnerich C. Bugawisan. And Teacher Annabel A. Rodriguez, our content editors. Teacher Rosabel R. Brillo, our language editor. And I'm Mrs. Benjelu P. Santiago, your radio teacher, saying thank you very much. Stay tuned for the live discussion, my dear learners. Have a nice day!
Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science.
Dance Radio, siniparalan sa radyo, atid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta mga tulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Okay, and we're back. Thank you, learners, for staying with us, no? During our RBI AWE. Yan, napakarami nating takeaways from the RBI lesson. Actually, ako mismo, no, personally, I appreciate the application of Bernoulli's principle, lalong-lalo sa pagkakaroon natin ng idea kung bakit kayang lumipad ng mga ibon, no, mga planes at iba pang aircrafts na tulad nito. Okay? And to have a better understanding on the Bernoulli's principle, let me welcome Ma'am Benjalu and Sir Ronnie for the deepening of the lesson. And guess what, my dear learners, we have also student guests, no, this morning in our live discussion. Yan, sino kaya sila? Makabang! Okay, so Ma'am Benj and Sir Ronnie, take it away.
Yes, thank you, Ma'am Mirna. Good morning, Sir Ronnie.
Good morning, ma'am.
Okay, kamusta naman ang ating araw?
Okay, magandang ating araw ngayon dahil maliban sa naka-live po tayo at last day, Friday.
Yeah, thanks God, it's Friday. At syempre, bago natin simulan ang ating discussion, nais ko din munang batiin ang lahat ng mga estudyante natin sa 10 SSC classes, ang aking mga anak na 10 Mendeleev, ang mga anak ko sa Advanced Physics, ang 10 Einstein, ganun din ang klase ni Ma'am Mirna na nasa 10 Rutherford. Ayan. So, ilan ba silang lahat ngayon, Ma'am Mir?
Actually, meron na tayo sa live audience natin, no? Meron tayong 42.
42.
Dadagdagan pa yung mga yan, babangon na sila.
Oo, kasi mukhang nasa higaan pa tong mga to eh. Pero at least naka-tune in sila sa atin, di ba?
And of course, yung 10 Mendeleev po. Ayan, good morning mga anak.
Yes. Okay, Sir Ronnie. So,
Yes, ma'am.
nabanggit mo nga na ngayon Friday. So, weekend, may mga weekend lakad tayo kasi papa-summer na, di ba, sir?
Yes, ma'am.
Yes, papa-summer na. Uso ang mga camping.
Yes, camping sa beach.
Oo, yan. Usually kapag nagbe-beach ang gumagawa sila ng campfire.
Campfire, ma'am.
Oo, nagproproduce sila ng apoy sa gilid ng beach. Ang tanong ko, Sir Ronnie, paano nga ba ang mga sinaunang tao ay nakakapag-produce ng apoy?
Yes.
Yan.
Paano kaya sila nakapag-produce ng apoy? Isipin natin, wala naman silang mga posporo nung panahon na yun. Wala silang lighter. Wala silang burner.
Oo.
So, makikita natin dyan sa image, sa PowerPoint, how do primitive people ignite fire?
Oo nga.
Okay.
So, usually sa mga napapanood natin, sir, at saka yung mga katutubo rin natin na mga kapatid, di ba? Mga kapatid nating Aita, mga dumagat, na lalo-lalo na nung hindi pa tayo sila nararating ng sibilisasyon, yung paggamit ng posporo o ng lighter, talagang ginagamit nila ito, yung paggawa ng apoy gamit ang friction. Tama, Sir Ronnie?
Yes, ma'am.
Yes. And syempre, para makagawa ka ng apoy, you need to blow.
Kailangan mo talagang hipan yan,
Oo,
ma'am.
kailangan mong hipan. Or sa Ilocano, kailangan mong puyutan. Ano ba yun? Dapat, yun, tama yun.
Yes,
Puyutan.
ma'am. Puyutan, hipan.
Puyutan,
Oh,
hipan. Okay, pero ang tanong ko dito, Sir Ronnie, apay no puyutan tayo, yan, yung ganyan. Bakit siya nakakapag-ignite ng fire?
Okay, paano siya nakakapag-ignite ng fire, 'di ba?
Oo.
Habang hinihipan natin siya. Parang napakasimple lang pero meron pala siyang kinalaman dito sa ating pag-aaralan ngayon, 'di ba?
Yes.
Hindi man alam ng mga sinaunang tao, mga primitive people before, pero meron talaga siyang principle sa science kung bakit
Yes.
nakakapag-ignite ng fire, Ma'am Benj.
Oo, yung palang simpleng pag-blow nila, meron palang physics principle na makakapag-explain kung bakit bakit kapag gumagamit ka ng blower or ng yung tubo na pinang-iihip natin doon, or kahit wala kang pang-ihip, mangipaypay ka or mag-blow ka lang, mag-ignite yung fire natin. So, sasagutin natin yan mamaya, mga learners, sa end ng ating discussion kung paano nga ba nakatutulong ang pag-blow sa pag-i-ignite ng fire. So, stay tuned in.
Yes, ma'am. Ayan, para mas maging interactive ang ating discussion for this morning, papasokin na natin sa screen ng ating mga students, guests.
Yes.
Natin from different section ng 10 SSC. Okay, Ma'am Benj, kindly introduce the representatives from your class.
Yes, ayan. Thank you, Sir Ronnie. Actually, may 5 akong nabudol dito eh. Ang dali lang din kausap ng mga to. Nag-invite ako, in-invite ko din sila. Pero syempre, tinanong muna natin kung kaya ba ng kanilang connection kasi kailangan stable ang connection nila. Para magkaroon tayo ng live interaction dito, maging mukhang klase talaga dahil nakakamiss din naman, sir, na meron tayong mga kasamang estudyante.
Nakausap.
Oo, ang hirap naman tayo nag-uusap-usap dito, di ba? Okay, so let me introduce to you the brave 5 of 10 Einstein. We have today 4 beauties and 1 view. So please wave your hand, boys and girls, as I introduce you. So first, we have Makaila Besa. Ayan, so hindi, hi, Mikaela. Ayan, thank you. And we also have Jasmine Medina. Hi, Jasmine. And then, we have Alexis Manzano. Ayan, hello, Alexis. We also have Sharina Lay Santiago. And, nasan si Sharina? Wave your hand, anak ko. Ayan, medyo siguro, ayun, hi! Okay, wag na tayong mag-off ng camera natin para kitang-kita tayong lahat sa screen. And syempre, the only thorn among the flowers. We have Jean Carlo Lintao. Nasaan si Jean? Yan, siyang unang-unang nag-accept ng challenge. Okay, welcome guys to our live discussion this morning.
Okay, thank you, Ma'am Bench. Patatapang yan mga yan dahil maagang nagising para lang dito sa ating live discussion.
Yes.
So, ayan naman po si Ma'am Mirna. Ma'am Mirna, introduce mo naman yung mga estudyante mo sa 10 special science classes.
Okay, thank you, Sir Ronnie. Ayan. Of course, hindi kami pakakabog, no? From Mendeleev and Rutherford, meron din kami. Ayan. So we have representatives from 10 Mendeleev and 10 Rutherford. Let us all welcome, ayan, Shakira Javier from 10 Mendeleev. Ayan. O, paki-open ang kamanap. Ayan. And of course, we have also Sai de la Cruz. Ayan. And Bea Cari. Ayan. So, ayan po, Sir Ronnie and Ma'am Bench, ang magigiting na Rutherford and Mendeleev student.
Ayan, syempre dahil magigiting sila, bigyan naman natin ng pagkakataon, Sir Ronnie, para makabati sila sa kanilang mga classmates. Kasi syempre, itong mga to, nasa screen ngayon, napapanood ng mga kapwa nila estudyante, ng mga friends nila.
Yes, Ma'am Bench. Sige.
Okay, simulan natin mula kay Sai. Susunod si Bea, si Shakira. Okay, sunod-sunod tayo. Uy, ang ganda naman.
Good morning po sa lahat. Good morning po, Ma'am Mirna, Ma'am Bench, Sir Ronnie. At sa lahat po ng mga live viewers natin.
Kinikilig si Sai, ah.
Okay. Thank you, Sai. Next.
Good morning, everyone. Shout out po sa mga classmate namin na maagang gumising para abangan kami ni Sai.
Siyempre, kailangan abangan, di ba? Thank you. Next. Okay, sino nang susunod dyan? Ayan.
Hello po. Sa mga kaklase ko po diyang Mendeleev, bakit daw po mag-isa ko po dito?
Oo nga, bakit nga ba mag-isa mo dyan? Ikaw kasi ang pinakamatapang.
Yung pinakamatapang na nag-accept.
Yes. May mga kinausap pero ikaw yung pinakamatapang na umoo. Di ba? Thank you, Shakira. Next. Sino susunod sa atin? May we have Alexis.
Hello po. Sa mga kaklase ko po, support niyo po kami. Huwag po kayong traitor.
Ay, ganon. Okay. Oo, kasi may labanang magaganap mamaya. They need your support. Okay, thank you, Alexis. Then, let's have Jasmine.
Hello po. Good morning po sa lahat.
Ayan, shout out ka naman. Shout out sa lahat ng crush ko dyan. Mga ganon. Ayan. So, yan si Jasmine. Medyo mahiyain siya. Then, let's have... si Mikaela tapos na? Mikaela,
tapos na Mikaela?
Tapos na ba, anak?
Hindi pa po, ma'am.
Halika na. Pasok.
Good morning. Good morning po sa lahat. Good morning po, ma'am. Sir.
Bagong gising to. Halata eh. Thank you. And let's have Jean Carlo.
Good morning.
Sorry, love you anak ko. Nakatago sa screen. Sharina. Ayan, nawala tuloy, no? Nagtampo na yata sa atin. Yes, balikan natin mamaya. Para ano. Ay, ayun.
Hello, ma'am.
Hello, ayan. Sige, anak ko. Ayan, so medyo may backlog tayo. Naku, sana makisama yung ating internet connection. Nakikita natin si Sharina, pero medyo ang audio natin ay putol-putol, Sir Ronnie. Okay? But anyway, thank you, Sharina, for taking the challenge. You're one of the bravest students in your class. Okay. So, siguro mukha ng handa, sir? Handang-handa na?
Mukhang handang-handa na ng ating mga students guests. Paniguradong ganun din ang ating mga estudyante na nasa kanilang mga tahanan na nakikinig ngayon at sumusubaybay sa atin. Paalala learners, kahit nasa kanya-kanyang tahanan tayo, siguraduhin sinusunod natin ang health and safety precautions against COVID-19. Di ba, Ma'am Bench?
Yes.
Hindi ibig sabihin na maluwag tayo ngayon, nasa level 1 na tayo. Hindi ibig sabihin na okay na ang lahat. Di ba? So, ibig sabihin na mahalaga pa rin ang pag-iingat natin. So, wag maging kampante. Our health is our priority. So, hindi pa nawawala ang pandemya. Andyan pa rin yan, Ma'am Benz. Kaya dapat, ingat pa rin tayo, mga anak.
Yes.
Okay, yes sir. Tama yan, Sir Ronnie. And syempre, kahit nasa kanila silang tahanan, ang participation sa discussion natin ay, of course, hindi mahahadlangan. Okay, so learners, just key in your answers in our comment box. At abangan din, of course, ang mga cues na dapat i-key in sa mga tanong mamaya. May mga nakaabang tayong prizes para sa mga mabibilis na makasagot ng ating mga katanungan. Okay, so nakiparticipate na, may load ka pa.
Yes, o diba?
Ganda ng tagline na.
Yes, nakiparticipate ka na, may load ka pa. O diba? Okay, siguro we can start, Sir Ronnie. So, last week kasi, sir, we had a discussion about Pascal's principle. So, let's have a short recall by answering few questions. Okay, so we prepared actually 3 questions lang naman to follow you up. How much you have learned from our last week's lesson. So, learners, i-comment po ang inyong sagot sa ating comment box sa mga nasa tahanan. Para naman sa ating mga student guests, dati na kayong nahati sa dalawang team. Yes. Ang pink team and white team.
Okay, may dalawang team pa tayo, Ma'am Benz. Pink and
white. Okay. Oo, kaya sila
kaya pala sila Pink at naka-white.
Yes, naka-color code sila, sir. So, naggrupo na sila dati bago pa tong ating live discussion. At alam natin, ginawa nila yung best nila para iplano kung paano sila mananalo ngayong araw na to. So, work hard guys for the win. So, are you ready, Kulay Rosas?
Okay.
Okay, so...
Mukhang mayel yan mga bench eh.
Mayel sila. Pakinggan nga natin ang Kulay Rosas.
Okay, the team A.
Sabay-sabay. Get ready. 1, 2, 3, go!
1, 2, 1, 2, 3, go. I think we are pink, don't you? We are pink, don't you?
Go!
Okay. Thank you. Thank you so much.
Okay, thank you so much, Team A.
Oh, get ready. Go, go, go. Thank you. Okay.
Ma'am Mirna, papahuli ba yung mga team mo?
Okay, so syempre hindi pa huhuli ang kulay puti. Nasaan ang mga kulay puti? Say your yell with action. Get ready. 1, 2, 3, go! Hoy, huwag kayo magpatalo. Hindi pwedeng smile dito, mga ante. Wala silang yell. May nag-yell dito. Okay, kulay puti. Pakita nga ang ating action sa bayang yell. 1, 2, 3, go!
Nakamute kayo.
Oh, nakamute. Huwag kayo mag-mute. Ayan. Sige. Alexis, ikaw mag-count. Puro kayo tawa, mga ante.
Pinapakita yung puting meeting.
Oo nga.
Puti sila.
True. Team puti.
Okay, game na po.
Okay.
3, 2, 1.
Einstein
Right here.
Right here. Ay,
teacher.
Okay. Thank you so much, kulay puti or team puti. So, sa mga students na nasa kanilang tahanan, i-type ang team na sinusuportahan ninyo. Type Rosas for the pink team and puti for the white team on our comment box. And let's see kung ilan na ang handang sumuporta sa kanilang mga pambato.
Okay, let's start, Ma'am Bench.
Okay.
Unahan ang dalawang team sa pagsagot. Just raise the letter of your answer. Makikredit lamang sa team ninyo ang point kung kayo ang mauunang magtataas ng letra plus dapat lahat ng members ay iisa ang sagot. Hindi pwedeng nauna nga sila ma'am pero yung isa B, yung isa D, yung isa A. So hindi pwede ma'am. Dapat pare-pareha sila.
Yes.
So ang point kung kayo lamang ang maunang magtataas ng letter plus dapat lahat ng members ay isa lamang ang sagot. Kahit kayo ang nauna, kung may isang na iba, nako, pasensya talaga, hindi talaga pwede ng bench. Bibigyan natin ng chance ang kabilang team to steal your points.
Yes.
Okay.
So ito unahan. Nako, sorry Ito medyo nadaya na tayo dito, sir, kasi na-flash ko na yung question number 1. Okay, but anyway. So, may chance din na manalo ang ating mga learners na nasa kanilang tahanan. Unahan lang po sa pag-comment ng letter ng tamang sagot. Okay, so here is question number 1. A change in pressure applied to an enclosed fluid is blank to all portions of the fluid and to the walls of its container. Letter A, not transmitted. B, transmitted undiminished. C, unequally transmitted. Or letter D, transferred. Okay, raise your answer at the count of 3. 1, 2, 3. Okay. Si Alexis kanina, hindi pa na meron na siya. Baba nyo muna. Baba muna. Okay. Pare-pareho ang kanilang sagot. Unahan sa pagtaas. Raise your answer at the count of 3. 1, 2, 3. Okay, si Shakira. Nauna si Shakira. Tama ba, Sir Ronnie?
Si Shakira.
Okay, anong team si Shakira?
Team Pink.
Rosas. Okay. Ang Team Rosas, ang tamang sagot ay Letter B. Transmitted undiminished. Diba nga, Sir Ronnie, sabi ng sa Pascal's principle, force or pressure applied in a confined fluid is not or is transmitted undiminished. Or
Yes.
ibig sabihin, hindi nababawasan.
Yes, ma'am.
So parang kapag ka tayo ay nagpre-press ng something na naka-confine ang content niya. Mamaya,
Yes.
baka may mabanggit kasi ako may tanong na related doon. Okay, so ang ating team, ire-record ko muna. Ang ating Team Rosas ay may 1 point. O, habol-habol.
Actually, Ma'am Benz, dito sa comment box, meron sumasagot din sila.
Yes.
Kaso nga lang, meron man una, kaso ang sagot nila, D.
Letter
Pero
D.
ang tamang naunang sumagot ay yung si Ronald Madraga 10 Einstein.
Yes. Okay, Ronald, pa-screenshot yan, anak ko. I-send mo sa akin. I-PM mo sa akin yan para maalala kong nakuha mo ang first question. Okay.
Let's have number 2, Ma'am Bench.
Let's have number 2.
Okay, ako na magbabasa, Ma'am Bench.
Yes,
Number
sir.
2.
Ay, ito na yung sagot pala.
Okay. Which of the following is not an application of Pascal principle? A. Car brakes. B. A manual car lift. C. Blood pump by the heart. D. An electric fan. 1, 2, 3. Raise your card, please.
Okay, nauna si Jasmine, sir.
Yes,
Nauna
si
si Jasmine. So, anong team color ni Jasmine? Pati ng damit. Team Puti. Taas nga ang sagot ng Team Puti. Validate natin kung tama ang inyong mga sagot. Okay, very good. Nako, patas na ang labanan. Meron tayong tie-breaking question. 3 questions lang talaga to para hindi sila magana, sir.
Pero alam mo, Ma'am Bench, ang unang nakasagot dito sa online natin, 10 Mulave.
Wow, meron tayong 10 mula.
Number 2, 10 Mulave, Charles Michael Fonseca.
Shout out naman. Hello,
So, ibig
anak
sabihin,
ko.
hindi lang science class ang nakikinig sa atin, Ma'am Bench. Merong
Ibang section
ibang
din.
section, yes.
Okay, sige. Sir, pa-screenshot nga ako niyan.
Yes, Ma'am
Para, thank you so much, anak ko. Noted. I-PPM kita mamaya. Charles Michael Fonseca ng 10 Molave. Thank you so much.
Sumunod sa kanya yung si Kelly Salivar ng 10 Mendeley.
Oo.
Ayun, si Kelly. Uy, anak ko yan. O, diba? Next. Okay, Ma'am Mirna, for the third question. So, ang tamang sagot dito sa question number 2 ay an electric fan. Wala naman talagang kinalaman tong electric fan na to sa Pascal's principle.
Pang second quarter yan, Ma'am. Electric and motors and generator.
True. Pero car brakes, oo. When you press the car brakes, yung
Pascal principle talaga yan, Ma'am.
Pascal yan. Gamit ka ng jack. Oo. And yung pag-pump ng blood. Yes, lahat yan Pascal's principle. Let's proceed to the third question.
Okay.
Ito, tie-breaking to. Ayan.
Okay, ako magbabasa, Ma'am Benz, para makinig sa pag-count lang magre-raise ng hand. Give one situation that describes the application of Pascal principle. I repeat, give one situation that describes the application of Pascal's principle. So, 1, 2, 3. Raise your hand.
Okay, nag-iisa. Nag-iisang matapang. Okay. So, we have Jean Carlo. Mag-unmute ka. Give us one situation that describes the application of Pascal's principle.
Ma'am, car brakes po.
Okay, car brakes. Paano natin masasabi na ang paggamit ng car brakes ay ginagamitan or ina-applyan ng Pascal's principle?
When the brake pedal is pushed, the piston in the master cylinder exerts a force on the brake fluid.
Okay.
Then, the resulting pressure is transmitted equally to the 8 other pistons.
Yes.
Eventually, the pistons forces the brake pads against the wheels and stop the car.
Yes. O, di ba, Sir Ronnie, pagka nagda-drive tayo, konting apak lang natin dun sa brake pedal, ramdam natin yung paghinto or pagbagal ng ating sasakyan. Ano ba kasing nasa loob ng brake tube, sir?
Meron tayong mga piece dito. Parang cylinder, ma'am.
Oo. Siyempre, kung walang brake fluid, kung walang brake fluid, hindi gagana ang ating car brakes. Yun ang nagbibigay buhay, di ba, Sir Ronnie? Oo. So, pag prines si si brake pedal, yung fluid na nasa loob nitong tube na ito, napress sila, nako-compress sila. Yung force na binibigay natin through our feet or foot, na-transmit doon sa brake fluid. At yun, it is transmitted undiminished. Hindi siya nababawasan. At yung force na yon ang nagpre-press naman doon sa brake pad para huminto or bumagal yung sasakyan. So that is an application of Pascal's principle. Actually, marami pa, sir.
Yes, ma'am.
Yes. Ma'am Mirna, ano pa ba yung mga pwede nating madagdag?
Okay, actually yung using of hydraulic jack to lift a vehicle. And yung simpleng pag-press ng toothpaste, no? From a toothpaste tube. Example
Yes.
yan.
Lotion, gel.
3 times natin ginagawa.
Okay,
yan.
mga nagpupunta sa dentist, ma'am. Yung mga
Oo.
upuan.
Yes. Sa mga barbero.
Yes.
O, di ba? Pwedeng ma-elevate yung upuan. Pwedeng baba, i-adjust.
Okay, dahil sa Pascal's principle yun, ma'am.
Yes. Ang dami pala nating mga applications.
And Ma'am Bench, dun sa ating online mga comments, marami ding sumagot. At ang una, dito sa akin nakita ay si Rin Jeline Visaya from 10
Oh,
Mendeliv.
10 Mendeliv. Anak ko yan. Oo, anak natin yan. Nak, screenshot at isend mo sa akin mamaya ang screenshot ng yung sagot sa ating comment box. Okay.
Like car brakes, brake sana. Siguro pag mamadali naging brekas.
Oh, di ba? Pero siya na rin yon. Okay. So, mukhang ano
Ma'am,
na?
Mukhang ready na sila, ma'am. So,
Yes.
we will proceed now sa ating next lesson, ma'am. So,
Yes.
itong next lesson natin, ma'am, talagang nakaka-engganyo itong mga next lesson natin. Magtataka tayo, bakit kaya nakakalipad yung airplane?
Oo nga.
Ano yung science behind?
Yes.
Diba? Bakit kaya yung design ng mga sasakyan ay talagang hindi pwedeng flat?
Oo.
So, ano yung principle behind? Bakit kailangan na gano'n?
Oo.
Kundi naman, bakit sa tuwing may bagyo, Ma'am Bench, yung mga bahay, mga bubong ng bahay, lumilipad na talaga natutuklap sila, ma'am?
Oo, buong bubong ka mo, sir.
Yes, buong bubong. So, hindi natin alam, may principle pala yan.
physics pala
So, yan yung
doon.
pag-aaralan natin, Ma'am Ben. So,
Yes.
I think, ma'am, the learners are now ready for the new learning, ma'am, sa ating new lesson. So, ano ba yung lesson natin yan, ma'am?
Okay, so we'll discuss about Bernoulli's principle. Ayan, alam niyo sa totoo lang nakakatuwa ang physics na lalong-lalo na pag na-apply natin sa mga nakikita natin sa paligid, ano? Okay, so ano nga ba tong Bernoulli's principle na to? Bago natin masagot yan, Sir Ronnie, magkakaroon muna ng demonstration tong ating mga student guests.
Sila mismo magde-demonstrate, ma'am.
Yes. Bago itong live discussion na to, actually, nagkaroon na sila ng collaboration, nagkaroon na sila ng planning. Meron silang mga kani-kanyang task sa grupo. Merong nag-lead sa kanila, may nag-demonstrate. Meron din syempre ang observer nag-take note ng kanilang mga na-observe. Para sa kanilang demonstration ngayon, makipapakita nila sa atin kung paano nga ba or ano nga ba itong Bernoulli's principle.
Yan yung nakakamiss sa face-to-face, ma'am. Talagang sila ang gagawa ng mga activities. Para makita nila kung, totoo ba itong tinuturo nila, ma'am o nila, sir?
Oo nga. Kaya nga, sir. Pero di bale, malapit na. Konting
Yes.
kembot na lang. Magkikita na rin tayo. Kahit paano, matuturuan na namin kayo kung paano talaga dapat kayong turuan. Ayan. Okay, so ang ating demonstration is titled Blow It Gently. Yun. So, dito gagamit ang ating mga student guest ng strip of papers. Sabi natin sa kanila kahapon, Sir Ronnie, mag-prepare sila ng...
Prepare sila?
Oo, para sa ating demonstration. So, what to do? Blow air on top of the strip of paper. Do it on the end where you are holding the paper and let the other end move freely. Do the blowing of air gently and observe what happens. This is the question that they are going to answer. what happens to the strip of paper as you gently blow air on top of it? And why is it so?
Oh, Ma'am Beth, ano nga pala mangyayari?
Paano nga ba? So, bigyan natin ng pagkakataon itong ating mga estudyante.
Sige, Ma'am Beth.
Sabay-sabay nilang ide-demonstrate. Pero mamaya, magtatanong tayo sa dalawang grupo ng kanilang sagot.
Ng observation nila, ma'am.
Yes, ng observation nila. Yan. Ito sila nung kagabi, talagang pinaghandaan ang labanan ngayong araw na ito. Okay, sige. So, let's start. Tingnan nga natin. Pakitaas nga po ang strips of paper. Patingin. Ayan. Sige. So, everybody, I want you to do the activity. Do or make or blow air on top of the paper and do the blowing of air gently. Okay, sabay-sabay. 1, 2, 3, go. Okay, so kasalukuyan, sila ay naglo-blow ng paper. Okay, mga learners na nasa kanilang mga tahanan, tingnan natin, i-observe natin, no? Ang galing. Tingnan nyo yung kay Shakira. Shakira, ulitin mo na ko. Ang ganda kasi nung ng paper. Malakas mag-blow si Shakira. Oo, okay. Isa pa. Ayun, ang ganda nung ng paper kay Shakira. Pero the rest, pakita nyo naman, huwag kayong ngumiti-ngiti dyan. Okay.
Okay. Side, talagang kailangan naka-side.
Oo, very gentle. Okay, 1, 2, 3, go. One more, sabay-sabay. Ayan. O, diba? Nakikita natin, ano bang nangyayari sa papel na glino-blow ninyo habang ginagawa ang demonstration. Okay, dahil kanina ang Team Rosas ay naka 1 point, bigyan natin ng pagkakataon muna ang Team Rosas na unang sumagot. Pero walang point ito babawi lang tayo ng konti. Okay, Team Rosas, ano ang na-observe ninyo as you blow air on top of the paper? Mag-unmute, anak ko. Anybody can answer.
Yes. Sa group nila, Sai, Bea, Shakira, and
Zarina. Sino sasagot? Sino ang sasagot sa inyo? Pag hindi naintindihan mula sa isa, pwedeng saluhin ng iba. Ay, saluhin ng iba?
Yeah. Buti may sumasalo pa.
May sumasalo.
Actually, may nagsasalta mang bench, pero hindi natin masyado.
Oo nga, hindi natin naririnig. Sino may magandang audio sa inyo? Mag-audio test nga tayo from Team Rosas. Sai. Mag-unmute kayo, mag-unmute. Mag-unmute mga anak ko para marinig kayo ng lahat. Dapat naka-unmute na kayo. Huwag nyo nang i-mute. Anyway, tahimik naman sa inyong mga lugar.
Okay, Sai?
Okay, go, Sai.
Hello po, ma'am.
Ayan. Sige, anak ko. Naka-mute man ata. Naka-mute. Sir, pa-unmute na lang silang lahat. Okay, Sai. Nawala naman si Sai. Sige, while waiting para maging maayos ang audio ng Team Rosas, pasalo natin muna sila sa Team Puti. O, di ba kahit magkalabang team? Okay, Team Puti, kindly check your audio. Mag-unmute ang Team Puti. Team Puti. Okay. Ano ang na-observe ninyo habang nag-blow kayo ng air on top of the paper strip?
Kagaya po nung nakita natin sa demonstration kanina, ma'am, yung nag-move upward po siya or nag-lift po siya yung sa strip po, sa paper.
Okay. Na-observe ba ninyong lahat yon? Kindly give a thumbs up. Even for our learners sa kanilang mga tahanan, mag-thumbs up nga tayo. Na-observe ba ninyo yung sinabi ni Alexis na nag-lift daw yung paper. Kahit hindi mo hinahawakan yung dulo, nag-lift siya naturally. Do you agree, Sir Ronnie?
Yes.
Yes. So,
kita yun dun sa ano ni, ano kanina ma'am? Ni,
Shakira. Oo. Yung kay Shakira kanina, ang ganda ng pagkaka, ng paper niya. Shakira, isa panganak. O, diba?
May buwelo pa.
Oo, may buwelo. O, diba? Ang ganda nung...
Walang dayan, hindi nila ginagalaw na ginagalaw ni Ma'am
hindi nila
Bensha.
ginagalaw. Pero
Hinihipan lang doon sa taas.
Oo, pero napapaangat nila.
Okay na anak, makapagod ka
Thank
naman.
Okay, mamaya gagamitin natin yung observation ninyo sa demonstration para maintindihan ninyo at ng mga kaklase ninyo ano nga ba itong Bernoulli's principle. Okay, ngayon, meron tayong second demonstration pero syempre kami naman, it's our turn. Si Sir Ronnie naman ang magde-demonstrate ngayon. Ang title nito ay Wag mo kong iwan sa ere. O, di ba may mga hugot naman sa mga kanina sa luhin. Okay, ngayon, anong gagawin ni Sir Ronnie? So, gagamit siya ng blower para mapanatili or para tingnan nyo, gagamit siya ng blower at ng ping pong ball. So, let's see what happens kapag nilagay ni Sir Ronnie ang ping pong ball dito sa ibabaw ng blower. Ayan. Nakikita ba natin, learners? Okay. Observe. Okay na, sir. Okay. Nahulog? Unang observation, nahulog. Pangalawa, sir, hawakan mo muna yung ping pong ball. Ayan. Saka mo siya i-on. Ayan. Sige, sir. Ayan. So, ano ang na-observe natin, learners? Gusto kong banggitin ninyo sa comment box kung ano ang nangyayaring kasalukuyan sa ating ping-pong ball habang naka-on ang blower. Okay, humanda rin ang ating mga learners na guest natin ngayon. Babalikan natin ang Team Rosas para sa kanilang observation. Ayan. Thank you, Sir Ronnie. Okay. Meron na bang sumagot?
Sa atin, ma'am, wala pa po eh.
Okay. So, wala pa. Pero, alam ko, nag-observe na itong mga estudyante natin sa bahay. Lalong-lalo na itong mga guest learners natin. Okay. From Team Rosas, what did you observe when the blower was turned on? What happened to the ping pong ball?
Ma'am, eto po. Ako po representative ng Team
Okay.
Rosas.
Sige. Sige.
Yung ping-pong ball po, ma'am, nagpa-float po siya.
Yes.
Dun sa taas po ng hairdryer.
Okay.
So the air is moving fastest right above the hairdryer, creating a zone of low pressure. On either side of the fast-moving stream of air are zones of high pressure. The additional pressure acts as a barrier, creating a zone of low pressure. When you tilt the hairdryer, the ball does not fall because it wants to stay in the low pressure zone.
Okay. Binigay kong assignment to, pero Sir Ronnie, yung grupo nila naghanda talaga, di ba?
Yes, ma'am.
Oo, sa na to. Actually, itong demonstration na to, pinag-aralan nila talaga kung paano nga ba nangyayari. Tama yung sabi ni Sir Ronnie, na yun daw bola, kaya siya nag-i-stay afloat habang nag-blow yung air kasi nga there is a pressure difference between the air doon sa stream or doon sa nilalabas ng blower at saka yung air na nasa paligid. Ang question ko, ano ba ang difference nung air na nilalabas ng blower at saka nung air na nasa paligid in terms of speed? Anybody? Kindly differentiate yung speed ng air between doon sa ini-stream ng blower at yung nasa environment. Differentiate the speed. May we have Mikaela.
Ma'am, yung based on my observation po, ma'am, yung nilalabas po na air ng blower is fast air, which is the low pressure, and yung air po na nasa bandang labas po is parang slower air po ma'am, high pressure. Kaya po nagli-lift up yung ping pong ball kasi po low pressure po yung air na nilalabas ng hair blower.
Okay, so nababanggit nila tong pressure, ano, Sir Ronnie? Tama. Okay, sabi niya, mabilis daw. The velocity or the speed of the air on the air column is actually high or greater than the velocity of the air outside the column. So there is a difference on the speed.
Yes, ma'am Ben.
Pag may difference on the speed, meron pala, sabi niya, may difference in
pressure.
in air pressure. So, tingnan nga natin, para mas lalo nating maunawaan, ano nga ba ang pagkakaiba nitong dalawang types ng flow, Ma'am Mirna? Kasi nababanggit nila mabilis tsaka mabagal. Okay.
Yes, ma'am. Thank you. Pero bago yan, congratulate muna natin yung winner natin dun sa tanong kanina, no? Okay, ang nakasagot po is from 10 Rutherford. Ayan.
Wow.
Okay, sabi ni Ira Asuncion, the ping pong ball stays in the mid-air as the blowers turn on. Okay, very
Wow.
good. So, ibig sabihin, Ma'am Bench, nanunood talaga sila.
Oo. So, tama yun. Nag-i-stay siya sa mid-air. Nananatili siyang nakalutang habang naka-turn on. Pero pag tinurn off natin yon, definitely, aalis na siya doon.
Aalis na siya doon sa position niya.
Mahuhulog na
Yes.
siya. Okay.
Okay, so congrats Ira, and going back no dun sa ating observation sa ping pong ball, yun nang nabanggit na ng mga anak natin, ang gagaling nila, Ma'am Bench.
Oo.
Okay, nabanggit nila yung high pressure, low pressure dun sa mga sa air coming from the dryer and then dun sa side, no? Dun
Oo.
sa okay, so actually we have an ideal fluid undergoes two types of fluid flow. At yan ay nakita natin dun sa ping pong ball demonstration natin. So we have the first one, which is the laminar flow, and the second one is the turbulent flow. So what's the difference between these two? Okay, so when we say laminar flow, okay, the flow in which the fluid travels smoothly or in regular paths. So nakikita nyo dyan sa ating slide, no, meron dyan. So, very smooth lang siya and regular yung ating path, no. So, in laminar flow, sometimes called streamline flow, the velocity, pressure, and other flow properties at each point in the fluid remain constant. Okay, so laminar flow over a horizontal surface may be thought of as consisting of thin layers or laminae, all parallel to each other. So the fluid in contact with the horizontal surface is stationary, but all the other layers slide over each other. Okay, so pag sa laminar tayo, okay, since it's regular, no, regular yung ating flow, yung ating path, the velocity is lower, no?
Lower.
Slower siya. Slow yung pag-move natin. Yun yung nababanggit na kanina sa ping-pong ball. So dun sa dalawang air doon, alin doon ang merong laminar flow? Okay, so nabanggit kanina ng ating anak na yung air coming from the dryer, higher daw ang velocity, faster. So therefore, yung air na nandun sa side, no, coming from the sides or dun sa surrounding, no, so yun yung ating
Laminar flow.
Okay,
Yes.
on the other hand, we have also the second type, which is the turbulent flow. Okay, so this is a type of fluid flow in which the fluid undergoes irregular fluctuations or mixing, in contrast to laminar flow. Ayan nga, nasabi natin kanina, in which the fluid moves in smooth paths or layers. So dun sa RBI natin kanina nabanggit, turbulent flow is violent, chaotic, and irregular. Okay, so dun sa ping-pong ball demonstration natin kanina, ang turbulent flow natin doon is yung air, no, dun sa ating air from the dryer nung na-turn on na siya. Kasi, and it has, of course, greater velocity or faster, no? Faster yung ating movement. And nabanggit din ng mga bata natin kanina, dun daw sa air coming from the dryer, higher ang velocity, but okay, sabi natin dyan, kanina sabi ng mga bata, may mga pressure, no?
Yes.
Okay, so mamaya natin mabanggit yan, baka ma-excite na ako. Okay, so those are the two types of flow, the laminar and turbulent flow. So ang key terms lang doon, pag laminar, smooth siya, regular, pag turbulent, irregular, and chaotic. So, and it goes with the speed. Siyempre, pag smooth, less ang speed. Okay, kapag irregular or chaotic, syempre faster ang ating speed or ating velocity.
Okay, so napakalinaw naman no nung explanation ni Ma'am Mirna ng difference between laminar and turbulent flow. So yung mga demonstration natin actually it can actually help us to explain the other phenomena that we observe na ina-applyan ng ating tinatawag na Bernoulli's principle. Ano
Okay.
nga ba to, Sir
Ano
Ronnie?
nga ba itong Bernoulli's principle? So, anybody can you state this principle sa mga guests natin? Sino makakapag-state ng Bernoulli's principle?
Okay, si
Yes,
Alexis.
Alexis.
Nagtataas si Alexis. Lakasan
Alexis.
anak ko.
Bernoulli's principle, also known as Bernoulli's equation, will apply for fluids in an ideal state. But in this case, fluid refers not to only liquids, but gases as well.
Yes.
Therefore, pressure and density are inversely proportional to each other. This means that a fluid with slow speed will exert more pressure than a fluid which is moving faster.
Okay, so na-mention niya yung speed and pressure relationship, di ba? Actually, yun talaga yung iniikutan ng Bernoulli's principle. So sa Bernoulli's principle, it states that tama yung sinabi ni Alexis, as the speed of a moving fluid, either liquid or gas. Sabi niya kahit daw liquid yan or gas, fluid pa rin naman siya. So as the speed of the moving fluid increases, the pressure within that fluid decreases. They are inversely proportional. And if its speed decreases, the pressure within it increases naman. So lagi nating tandaan yung learners, yun lang yung dapat nating matandaan dito. Habang tumataas ang speed ng fluid, ang pressure bumababa.
Yes, bumababa naman.
Pag naman bumabagal ang speed niya, yung kanyang pressure tumataas. May kinalaman kasi ang pressure na yan, sir, sa difference in pressure sa iba't ibang mga applications
Yes,
natin.
ano ba yung mga application na yan, ma'am?
Unahin
Yan,
na natin.
unahin natin yan. How do airplanes generate a lift? Mahalaga yung lift, ma'am, dahil di mo makakalipad yan airplane nang wala yan.
Pero pansinin natin, Sir Ronnie, ang mga airplanes natin, meron silang disenyo ng...
Yes, yung engineering design niya
Oo,
talaga.
may aerodynamics na tinatawag, lalo na dun sa kanilang mga wings.
Yes, ma'am.
Okay. So, gamit itong ating diagram dito, gusto kong tanungin sa ating mga estudyante, how do airplanes generate a lift? Anybody? Sino ang nais magbigay ng idea? Paano nga ba nakakaangat? Uy, si Shakira, meron siyang airplane. Gawa sa papel. Shakira, sige anak ko.
Magaling siyang gumawa ng papel.
Oo.
Airplane.
Yan pala ginagawa mo habang nagdi-discuss tayo rito. Sige, Shakira.
So basically, the wing's upper surface is curved so that the air rushing over the top of the wing speeds up and stretches out.
Yes.
Which decreases the air pressure above the wing. It then becomes a low pressure air. In contrast, the air flowing below the wings moves in a straighter line. Ganun po.
Okay.
Thus, its speed and pressure remain about the same. It remains high pressure po.
Okay.
Since high pressure always moves toward the low pressure, the air below the wing pushes upward toward the air above the wing. Papunta po sa yung low pressure po papunta sa high pressure.
Okay.
The wing in the middle is then lifted by the force of the air perpendicular to the wing. Nabubuhat niya po.
Okay.
The faster airplane moves, the more lift there is. And when the force is greater than the force of gravity, the airplane is able to fly. And because of thrust, the airplane is able to move forward in flight. To sum up everything I've said, the factors that enables a plane to fly is the wings' shape, which is the curved one, and the pressure around it.
Yes, tama. Ang galing, no? Ang ganda na explanation niya. May kinalaman yung curve.
Yes.
Yung aerodynamics, yung curve na
ang
shape
ganda ng model niya ng aeroplano, Ma'am Bench.
yung curve na ng wings niya. Kasi Sir Ronnie, dyan sa taas, hindi naman talaga, streamline ang
Yes,
air
ma'am.
dyan. Hindi siya malikot. laminar ang flow. Pero kapag kapareho ang air pressure, walang push na magaganap.
Hindi siya lilip.
Oo,
Yes,
hindi
walang
siya-
lift.
Walang lift.
Walang lift.
So,
sa
para
tinatawag mo.
magkaroon ng lift, dapat may difference in air
Air
pressure.
pressure.
Pero, dapat yung differencer, ang mangyayari, ipupush niya pataas.
Pataas.
Ang tanong, paano ba tayo makakapag-push pataas? Dapat ano ang nasa baba? High pressure ba o low pressure?
Dapat high pressure, ma'am.
Dapat high
High
pressure.
pressure.
Paano magkakaroon ng high pressure doon?
Okay, kapag laminar yon o steady lang yun,
Yung air,
Yung air.
yung airflow dapat laminar lang.
Ah.
Pero yung nasa taas dapat maging turbulent. Okay, paano magiging turbulent yon? So, yun yung gamit ng aerodynamics ng wings ng ating mga planes. Okay? So, dahil curve siya, ang tendency yung hangin sa taas, magkakaroon siya ng turbulence doon. So, magkakaroon ng increase sa speed or velocity ng air. And, ang mangyayari, nag-increase ang velocity, bababa si pressure. So, if there is lower pressure on the top of the airplane and higher pressure on its bottom, the tendency is that it will have a lift.
okay, ma'am. So, yung design niya, it speeds up the velocity of the air doon sa taas, ma'am.
Yes, sir. Tsaka kahit yung mga nguso ng eroplano, talagang pa-curve din talaga para makagawa sila ng laminar flow sa taas. Kahit sa mga ibon?
Yes, ma'am.
Oo, sir. O, tingnan natin dito. Yung design ng airplane, wings, at yung wings ng ibon, may pagkapareho sila. No? So, even other flying aircrafts. Okay, so, thumbs up nga tayo kung malinaw, naintindihan ba how airplanes gain a lift? Thumbs up nga po, even for our learners at their homes. Kindly comment box or mag-thumbs up po sa ating comment section. Next application. To, nako.
Why are roofs sometimes blown by strong winds during typhoons? Yung ba talaga dahil sa sobrang lakas ng hangin, ma'am Bench? Or may kinalaman talaga sa magkaiba yung pressure doon sa labas at sa loob ng bahay?
Oo nga. So, tanungin ko nga itong mga estudyante natin kung talagang naintindihan nila ang konsepto ng Bernoulli, kaya nilang i-explain. Bakit yung buong bubong naman, iniisip mo yung gym, halimbawa, may mga ganun, di ba, sir?
Yes, ma'am Bench.
Buong bubong ng gym, nililipad ng hangin. Paanong nangyayari yun? Napakabigat nun. So, is it because of the strong wind on the top of the rooftop, or other wind na may kinalaman dito? Or anybody who wants to explain why are roofs sometimes blown by strong winds during typhoons? Sino ang nais mag-share ng kanyang idea rito? Okay, yes. Si Jasmine. Sige, si Jasmine. Sige anak, naka-unmute ka naman na.
Pag po may bagyo, turbulent po ang air sa labas, low pressure po. Pero kapag sinara po lahat ng doors at windows ng bahay, nananatiling high pressure po yung sa loob ng bahay. So ang gagawin po ni high pressure, pupunta po siya sa low pressure, itutulak niya po yung kaya niyang itulak, kaya po nalilift yung bubong.
Okay, tama ba yun, Ma'am Mirna? And Sir Ronnie? Sabi ni Jasmine, ma'am, kasi sa labas, habang typhoon, ang hangin turbulent.
Yes, ma'am.
So, dahil turbulent yan, fast ang speed niya, low ang pressure niya. Pero yung nasa loob ng bahay, nasa loob ng bodega, nasa loob ng gym, dahil hindi naman gumagalaw halos yung hangin doon, laminar siya, so high ang pressure. Itong high pressure area na to, or air with high pressure, ang gusto niyan pumunta sa low pressure. So, ang tendency, ipupush niya pataas. At kung hindi naman strong enough yung pagkakakabit ng bubong,
talagang ililipad niya.
Ililipad niya ng buo. So, yun yung dahilan kung bakit nakakakita tayo ng mga buong bubong na nililipad during strong typhoon. So, di ba may kinalaman palang Bernoulli's principle dito? Kaya, pasok natin yung mga safety precautions natin sa DRRM sa MAPE, sir. Kailangan pag ganito,
maging maingat tayo sa ganitong mga panahon, Ma'am Bench. Hindi lang
handa.
laging handa.
Siyempre, pag may ganyang bagyo ka nang lalabas. Mamaya lumilipad yung mga bubong ng kapitbahay nyo, di ba? Laging handa talaga tayo, matama.
Huwag na magbibideo sa labas, di ba, Ma'am Bench?
Oo, yung iba kasi unahin mag-video muna. Ganito kalakas ang hangin sa aming lugar. Mamaya na itupakan kanti, Kwan. Okay, next. Punta naman tayo sa pier.
Okay. Why are piers and boat docks usually made of wooden stakes and with water underneath instead of solid concrete block?
Totoo yan, Sir Ronnie, Ma'am Mirna. Parang wala pa akong nakitang pier na purong solid. Meron talaga siyang daanan ng tubig sa ilalim. Pwede rin na metal or aluminum or konkreto, pero yung ilalim, it's not a solid block. Oo. Bakit kailangan may daanan? Ano ba ang dahilan? Ipasok natin si Bernoulli's principle dito. Sino ang gusto dito mag-explain? Meron ba? May idea ba kayo? Okay, wala yatang nagtataas ng kamay. So, Sir Ronnie, siguro panahon na para saluhin naman natin sila.
Ma'am Bench, sige.
Okay. Kasi sir, ang mga pier and boat docks, ito yung dinadaungan
Ng mga barko.
ng mga barko, ng mga bangka. Siyempre, lalapit si bangka dyan. And, pag lalapit ang barko or bangka, definitely, kahit laminar yung flow ng water, magiging turbulent yung nadadaanan niya. So, pag merong part na turbulent at may part na laminar, may low pressure and high pressure, ang tendency nun, ipupush ni high pressure si low pressure.
Yes.
Okay, dahil si boat ang nagmo-move, ang water na pinupush niya, nagiging turbulent ang flow, low ang pressure. Pero si water na nasa outside nung daanan ni boat ay nananatiling laminar. So ang tendency, itutulak niya ngayon yung tubig, yung water na low pressure. Yung high pressure, itutulak niya si low pressure. At kung dadaong siya dito, ang tendency, mag-i-islam siya doon.
Sasadsad siya, ma'am.
Sasadsad siya dito sa pier. Okay, pero kung hindi po open yung ilalim ng pier, kung hindi open hindi open for water, hindi makaka-flow yung tubig. So, ang tendency nun, pag sadsad niya, sasalpok siya sa pier, at the same time, malakas yung alon, pwede rin niyang sirain ang pier and boat docks. So, para less accident. Yan, yung konsepto niyan. Okay ba? Okay ba? Thumbs up naman. Naintindihan ba? Okay, thank you. And comment nga po, okay na okay, kung talagang naintindihan, kung bakit ang mga pier at boat docks ay gano'n ang kanilang disenyo. Naku, ang gano'n oras ba tayo, sir?
9:30?
9:30? Okay. So, mabilisan na tayo. Bakit dusty roads? Nako. Last ng estudyante to. Bakit nagkakaroon ng dusty roads kapag may mga fast-moving vehicles? Anybody? Yes, Makaila.
Ano po, as the RBA have said, when a car or truck moves faster, it creates a lower pressure. It means yung parang yung mismong pinagdadaanan po ng sasakyan is nagka-create po siya ng low pressure, which is yun yung nagpo-pull sa dust or naisasama kaya po siya nagiging dusty road. It means yung nasa labas niya po or parang nasa paligid is high pressure po siya, and then yung nasa loob is low pressure po.
Yes, very good. So nakukuha na natin ang konsepto na ang dali na nating ma-explain. Ganon din, hindi tayo safe na mag-stay na malapit sa madaanan na may mga fast-moving trains, trucks, and vehicles. Kasi yan, Sir Ronnie,
parang ang pakiramdam, parang ang hinihila, Ma'am Ben.
Oo, hinihila ka talaga. It's not parang, hinihila ka talaga papunta doon. Kaya nga may mga na-aksidenteng mga bikers na gumigilid sa mabibilis na sasakyan, na hihigop sila. It's not an accident. Actually, it's an accident. Pero, ang explanation, physics principle pa rin. Yung fast-moving vehicle, low pressure yung air doon, high pressure sa paligid. Magaan ka, yung bisikleta mo magaan tendency, tutulak ka papunta sa gitna.
Kaya kung makikita sa picture, ma'am, dyan sa train na yan, meron siyang yellow
line.
Dapat wag kang magkocross dyan, ma'am, pag meron train na dumadaan.
Ang tendency, higupin ka niyan. Okay? So, yan. Last na. Last na, Sir Ronnie. Sorry for the time. Mag-overtime tayo kahit 2 minutes lang.
Okay pa, 2 minutes pa, ma'am. Kaya pa yan.
Okay.
Why do smokes naturally go out through chimney, Ma'am Bench? Bakit natural, hindi sila pumupunta dun sa
Saan-saan?
sa loob, di ba ma'am?
Oo.
Nga, ba't yan tumataas, hindi din mag-usok sa buong bahay?
Nasa sala yon, tapos ang enjoy nila, pinapainit nilang paligid sa mga malalamig na lugar, pero yung usok hindi napupunta sa kanila.
Yes, sa taas.
Okay, nasa taas lang lumalabas ng chimney. Ang dahilan niyan is that yung labas kasi ay may hangin na nagsisirculate. So, ang air dito is turbulent. Pero sa loob ng bahay, laminar lang, steady lang ang hangin dyan. So, tendency nga, from high pressure, ipupush niya yon papunta sa labas, low pressure. Ang nagkataon, chimney, daanan yan, labasan. So, lahat ng usok na nandoon na nabubuo dahil sa pag-burn, lalabas yan naturally sa chimney. Okay. May question ba, learners? Mag-wave kung may questions. Mag-thumbs up kung wala.
Okay, mukhang... Okay, nag-thumbs up na sila ma'am. Mukhang naintindihan nila.
Okay, nagta-thumbs up din sila. So mukhang malinaw na sa kanila kung ano tong... Okay na okay. Thank you so much. So, it's time for us to know how much they have learned.
Yes.
Okay, siguro Sir Ronnie, mga 3 questions na lang yung i-ano natin dito.
Okay.
Tanungin natin. Okay, learners, prepare your letters, yung mga guests natin, and para dun sa mga estudyante natin online, i-prepare ang inyong mga daliri sa pagpindot ng A, B, C, D, or E. Ano? Depende sa tanong. This is our question. Question number 1. According to Bernoulli's principle, when a fluid's pressure decreases, what happens to the speed of the fluid? A, it stays the same. B, it decreases. C, it increases. Or D, it becomes variable.
Okay, sige. Tingnan natin yung mga sumasagot dito.
Nakakat na kami. Okay. So, ano ang sagot natin dito?
2 minutes.
Okay, 2 minutes. Pag tumaas si pressure, okay, our answer, let me see. It's letter C. Okay. So, lahat naman sila nakakuha ng tamang sagot. I-credit natin pareho.
Okay, number 2.
Okay, number 2. Last na to kasi...
Why is the top of the airplane's wing curved? A,
Okay.
to create an area of low pressure above the wing. B, to create an area of high pressure above the wing. C, to create equal pressure above and below the wing. D, to create an area of low pressure below the wing. Or E, to make the wing look very cool.
Okay, raise your answers at the count of 3. 1, 2, 3. 1, 2, 3. Okay, ang hirap tingnan. Sige, credited sa lahat ito. Thank you. To create an area of low pressure above the wing. Okay, so tingnan natin, sir, ano ba ang nare-reflect ng mga learners natin? Makinig tayo kahit isa lang sa kanila ng reflection. Okay, Mikaela, ikaw na nga anak ko, malakas ang boses. Ano ang reflection mo buhat dito sa discussion natin ngayong umaga? How do you relate Bernoulli's principle to your life as a student?
Ma'am, ano po, magbibigay na lang po ako ng example.
Yes.
Example po is yung, di ba po kapag nasa room po tayo, syempre kapag iniinit po tayo dito sa room natin, binubuksan po natin yung window natin.
Yes.
Para pumasok po yung cool or fresh air. Pero kapag binuksan po natin yung window natin, hindi rin po magbabago yung temperature. Kasi po, naka-close pa rin yung door, which is yung hot air nananatili pa rin po sa loob. Or dun sa may closed door, nandun po yung high pressure, kaya dun na-built up yung hot air. Kaya kapag binuksan mo po yung door, lalabas po yung hot air kasi nandun po yung low pressure. Yun, ina-attract niya po yung hot air. Yun po
Okay. So, nare-relate niya to sa convenience niya. Convenience sa bahay, sa classroom, siguro. Okay. So, thank you so much. Nakat na ba kami, sir? Okay. Thank you so much, Mikaela, and to our learners. Sa mga winners po natin, please, paki-PM po ako para sa inyong load. And syempre, dito sa ating mga guest students, lahat kayo may premyo.
Okay.
Thank you so much.
See you soon.
Oh my God, kahirap ihabol.
In finding new knowledge and help help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is Science. And now, here is your host for the day. Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan. Ang istasyong magbibigay impormasyon kahit saan man.
For something big. Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR FM.